Very good evening, everyone.
Good evening, sir.
Very good evening, Subhajit.
Good evening,
Welcome
sir.
everyone to the class.
Good evening, sir.
Very good evening. Nakul, Varat, very good evening.
Good evening, sir.
Good evening, sir.
Good
Very
evening,
good
sir.
evening. Good evening, Viral. So I don't know, half of the voices I cannot recognize. You have to end with your call sign if you don't have videos on, students. Remember. Otherwise, I'll not know who's saying good evening also. Manan, good evening. Viral, good evening again. Pankti, Vivek Yadav, Mohammad Azam, Nandini, Nehal, Vivek Dakar, and Sparsh. Good evening and welcome
Good
to the
evening,
class,
sir.
students.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
And I have Twarita and Sujal joining us. Good evening, Twarita and Sujal.
Good evening, sir.
Students, a quick go through of all the points we had discussed yesterday. What is departure? What is rhumb line? What is great circle? What are meridians? What are longitudes? What are parallels of latitudes? There's a sign, there is a cause in our formula. What are those formulas? What was the last equation that we did? We were finding the great circle distance by determining the great circle between those 2 points. It could be d lat or it could be d long. One thing has to be common, either the great circle, which is equator, if you are doing d long, and the other would be a d lat if you are on any meridian and prime meridian and anti-prime meridian, or any meridian and its anti-meridian. Falak, good evening, welcome to the class. How do you read? Falak, I cannot hear you. Read you 1.
Read you 5, sir. Good evening.
Good evening. Good, I can hear you. Falak, in case you have not gone through a couple of sessions in the past, just follow as much as you can today and write down your doubts. Okay.
Okay, sir.
So we don't have Likhit, we don't have Prakash, and where is Sankalp? Sankalp is not there. See if you have any questions, students. We have limited time today, but we don't have much to do. We just have to solve a few questions. I'm going to show you all how to solve those questions. And then that's it. After the session tonight, I'm going to share practice questions with you all. And tomorrow, you have to use the time today and tomorrow to solve those questions and send me your answers. Okay. So there'll be around 20 questions or so. They'll be tricky. Do not use any other textbooks to solve them. Use your notes. And we'll see how much you're able to solve. So I'm doing a final attendance check. So please see if you have any doubts. Again, don't miss the opportunity right now. I want somebody to tell me what is the definition of departure. Write the answer in the chat box. Okay, departure. What is departure? So we have Manan, we have Nandini. Yes, we have Mohammad Azam. Pankti, we have Palak, Mr. Yadav, Subhajit, Viral. I think we don't have Viral today. Okay, we have Viral. I remember seeing you here. Varad is there. We don't have Ayan today. Okay. So Prakash is joining now. Nehal, how do you read, Nehal?
Read you 5, sir.
Good to have you in class, Nehal. Sparsh, how do you read?
Read you 5, sir.
Good to have you live, Sparsh. Victor Tango Zulu Alpha Yankee, Mumbai ground. How do you read? Jai Prakash.
Radio 5, Victor Tango Zulu Alpha Yankee.
Good to have you live in class, Jai Prakash. Very nice. Sujal, are you there? Vivek Dhakat is there. Twarita is there. Twarita, I hope you're feeling all right with every passing day.
Affirm, sir.
And we don't have Likhit today. Great. So, I'm getting answers. I've got one answer. Departure is the distance which is calculated from starting to destination point in DMS. Whereas, the answer is not correct. Keywords are missing. Okay. Take your time, go through your notes. Remember, it's all about keywords in aviation. Viral, your answer, departure is also called as rumline distance. Yeah, it is close to the correct answer. You can say that. I will take that as an answer. Nandini, departure distance between two meridians along a particular latitude. Perfect. That's the perfect answer. Departure is the distance between any two meridians along a particular latitude. That's departure, as called as, also called as a rumline distance. Good. Nandini, good job. See, it's all about keywords, students. We have to stick to keywords in our definitions. Victor Tango, Sierra Hotel, Romeo, Shata, how do you read? Join. I'm checking more answers. Shata, Victor Tango, Sierra Hotel, Romeo, how do you read?
Radio 5, Victor Tango Sierra Hotel Romeo.
Great, great. Shraddha, we are discussing, I'm just asking everybody to revise a quick revision about all things done. And the question that we have to answer in the chat box is, what is departure? Okay, so please write down the answer. What is departure in the chat box? Also have Likhit joining us. Likhit, how do you read?
Radio 5, sir.
Great. Likhit, in case you have not gone through previous sessions, just learn as much as you can and write down your doubts. I'm not sure if I've gone through the session, but I think you're missing. No, you're not missing. You were there, yes. Likhit, the question asked is, what is departure? You have to write the answer in the chat box. What is departure? So I am checking Sujal's answer. Departure is the distance between two meridians along the parallel of latitude. Perfect answer, Sujal. Good job. Viral has given another answer. It's the distance between 2 points in actual meridian spacing between 2 points at a given latitude distance. Good try, Viral. A little bit of complication I can see, but I will take this as an answer because key points are there. Make sure you're thorough with the points. Answer looks correct, but I think there are chances of misunderstanding in this one. Then Subhajit, departure is drumline distance between 2 points, which is a distance calculated along a constant direction. It is max at poles and 0 at equator. Subhajit, wrong. You're mixing two concepts. How can drumline distance be max at poles when at a pole we are at only a point? It is max at the equator, d long 1 degree 60 minutes, only on equator 60 nautical miles. So you're mixing it with what you have learned for convergency.
Yes, sir, I got confused, sir.
Yes, I can see that, but be very careful. Good effort. Partial answer is correct, but you mixed two concepts. It is calculated as d long in minutes into cos lat. Good that you have also mentioned the formula. Very nice. But that one point is wrong. It is maximum at poles and 0 at equator. Convergency is 0 at equator and maximum at poles. Okay, good, good. Mohammed Azam, departure is also known as rhumb line distance. Add that distance to your rhumb line. You cannot say departure is also a rhumb line. It's a rhumb line distance. Cutting Earth's surface equally. Cutting Earth's surface or cutting all meridians at an equal angle. That is again rhumb line. Good. But what is departure? You have not mentioned. A key point is missing. Departure is the distance along that parallel or a rhumb line measured between any two meridians. I hope you're following, Mohammed Azam. Vivek Yadav, departure is distance between 2 points,
Yes, sir.
actually meridian spacing between two given latitudes. A little bit of confusion, Vivek Yadav. It's spacing between two given meridians on a given latitude. One latitude, two meridians. Is it clear, Vivek Yadav?
Yes, sir.
Mohammed Azam, you have added max at equator, 0 at poles, correct? That is departure. Likhit, it is a distance between 2 points at any given latitude. You would say distance between two meridians. That d long is very important. You will not say 2 points, you will say 2 meridians. That d long is very important. Likhit, I hope you are following. Manan, rhumb line distance are known as departure distances. Good. Makes sense. Keywords are there. You can add more to your answer, but this much is also correct. You can add more things to your answer, Manan. So, Subhajit. Yeah, I've got the message, Subhajit. Yeah. Correction, rhumb line distance. Good, Mohammed Azam. But whenever you're correcting your answers, make sure you give a whole correct answer again in your chat box. Shraddha's answer, rhumb line distance are also called as departure distances. It is maximum on equator, minimum at poles. It is the meridian distance between 2 points at a given latitude. Absolutely perfect, Shraddha. All 3 points are absolutely correct. Good job. Properly detailed. One more thing you could add is the formula. This is correct. Make sure we remember the formula. Vivek Dhakar, distance along parallel between latitude. No, wrong, Vivek Dhakar. Distance along a parallel between two meridians. How can you say between latitudes? It's d long in minutes into cos lat. Following?
Roger.
Yes. Anybody who wants to debate the answer with me, please feel free to do it. If you have a point where you can explain your answer, you think you're right and I'm saying you're wrong or partially wrong, feel free to discuss, okay? Pankti, departure is distance between two meridian at any given latitude. Perfect. Good job. Bharat, you have corrected your answer. Departure is the distance between two meridians. It is also called rhumb line distance on a specific latitude. Departure is d long into cos lat. In the formula, you will mention d long into minutes. Okay, make sure so that we don't confuse. So the more correct your answer becomes, the more refined your answer will get. It is like that. Sir. It is correct. Shraddha, you made a correction 0 at poles, but in your answer and minimum at poles, it is same. Minimum 0 is minimum. So you are right. Your correction is also right. Earlier statement was also right. Nukul, departure is a rhumb line which is starting from point A to point B, which is parallel to equator or small circle. Correct. Points are valid, but the definition is not complete. The departure is a rhumb line distance between meridians with a start point from A and on one meridian to destination point B on another meridian, you could add. It's meridian to meridian on a given latitude. These latitudes are rhumb lines or parallels to equator or parallels to other small circles. That is right. So answer is correct, but 2 key points are missing. Yadav, I have got it. Departure formula, d long minutes into cos lat. Keep it up. See, students, what is taught to you and what you have learned and understood might match, but the true reflection of how much you have really understood is in your ability to give correct answers. Okay, and you all are doing a great job. All right, I can see that everybody, most of you all have given me a perfect answer, and whoever has not given me a perfect answer, I know you have understood it logically, and this is your learning that you have to make sure that you remember how to give an answer to a question. It's all the key points. It's not just how to give an answer, it's also about how to remember and understand what we are learning. But definitely, I do know that you have understood it. You have to just relate with these points so that you don't get confused. If you miss the keywords, chances are 15 days afterwards, if I give you the same numerical to solve, without any revision, you might be confused and you'll not get an answer to solve to that question properly. So please stick to the keywords. Make sure that you're participating in all such activities like giving answers and discussing, because it really helps me see where you're missing, what you're missing, and it will only help you. See, it's very rare these days to get personal attention for you as a student, okay? It is very rare. If you're getting it over here where you're learning, so make the most of it, okay? Because you're very lucky to get such kind of personal attention. It's not easy, okay? And now that you're getting the most of it, make the most of it. Simple as that. By discussing, learning, discussing. Great students, good job. Very happy to see your answers. Today we are going to simply solve a couple of questions with respect to braid circle, drumline, convergency, and departure. I'm going to show you a few methods that are easy to use. And then as said, before the end of day today, I'm going to send you what do we say? Practice questions as well as certain notes to read based upon this topic. So I think tomorrow, with respect to navigation, you might not have a navigation session because I would want you to submit your answers by end of day tomorrow. Okay. So that is something that I have planned so that you get enough time to solve it. And tomorrow before end of day, you can send me your solutions via email. All your assignments you'll send via email, not on WhatsApp. Anything else that I request specifically for WhatsApp, you can share it on WhatsApp. Now I'm going to share a few pictures. And then we are going to look at the numericals. Just give me a moment while I pull it up. In the meantime, if you have any doubts, please feel free to speak. Now, it is very important that we understand this relationship between the meridians and the latitudes and the distance between the meridians and the latitudes. This diagram shows that from the North Pole, any two meridians that diverge away from each other, they are diverging away, they're going away from each other. At the North Pole, they all are located in one point. And from the North Pole, they all are spreading like this, equally like this outside. They're diverging. By the time they reach equator, they become parallel to each other. So all meridians are actually parallel to each other only on the equator. That's why the convergency angle, the angle of inclination between 2 points, that is convergency maximum at the poles and 0 at the equator, because on the equator they're parallel to each other. Now, an interesting fact is, if anybody ever tells you what is the maximum convergency between two longitudes, and if I would say the two longitudes have a separation of 70 degrees, d long is 70 degrees, then what is the maximum convergency? If d long is 70, then the maximum convergency is also 70, because they are separated by 70 degrees between each other. And that maximum convergency is experienced at the poles. So if you look at that angle, this angle near the poles, this would be similar to the d long distance. Although the d long will be max at the equator, the angle of inclination would be 0. But the d long would be 70 degrees, then the angle at the North Pole would also be 70 degrees. Remember this point, okay? Don't just randomly say at the North Pole maximum convergency is 90, not necessary. If you have a prime meridian and an anti-prime meridian, then the convergency between the two will be maximum at poles, which would be 180 degrees, because the d long between them is also 180 degrees. So at max, the convergency could go up to 180 degrees between two meridians, or if you're taking two meridians next to each other with 1 degree difference, so either the convergency would be 1 degrees, the smaller angle, And the bigger angle would be then 359 degrees. So we don't take the longer angle, we take the shorter angle like that. So meridians diverge from the poles parallel on the equator, and then again as they move the south pole, they converge on the south pole. So this convergency is what we say. We don't call it divergency, we call it convergence, because they are always converging, but from the north pole they are diverging out. Now, if you look at this point or this diagram, again we can see two meridians and a tangent drawn on these meridians over the equator. This line here on the equator and this meridian on the equator, they are acting as parallel lines. But as you move on at a higher latitudes, the meridians start to converge. And this angle that you see between the two over here can be determined as a relationship between the convergency angle and the two meridians. Now this is departure distance, the distance along any parallel of latitude, one common parallel latitude, which also becomes rhumb line because of its constant direction. The distance is high on lower latitudes, maximum on equator. And as you move up, the d long, although the d long would remain the same. Let's say it is 60 degrees over here. D long 60, D long 60, D long 60, D long 60, D long 60. But the physical length of the distance is small compared to what was there on the equator. So this is departure distance maximum over the equator, 1 degree 60 nautical miles, and lower and lower and lower as you reach the poles. And over here on the north pole, it is 0. Minimum. Got it, students? Clear? And see, this is how the convergency angle is maximum at the poles. A straight line measured will be equal to the d long. That's it. Whatever the d long is between would be the convergency maximum angle between the two at the poles, between the two meridians at the poles. Good. All your basics are clear. Now, who can tell me the definition given to you of our convergency angle? Was it the difference between the great circle and the rhumb line track? Do you remember that line written down somewhere in your notebook yesterday? Can you look at it, students? Can you give me an acknowledgement? There are actually two definitions for your convergency, okay? One is, it is the inclination. One is, it is the inclination between the two meridians. Or it is the difference between. So I'm going to give you the second definition today for convergency. So this was convergency. Inclination between two meridians at a given latitude is called convergency. Convergency at equator is 0, max at poles. Convergency formula, convergent angle. Convergent angle is the angular difference between great circle track and rhumb line track. This is very important, okay, this point. It's going to make your numericals very easy. And convergence is a determinant factor in the change of true great circle direction involved. So this convergency and the change in the true great circle direction is where we have to add one more definition about convergency. Okay, so please add it in today's notes, and you can add the same in your notes wherever you have written down convergency. And this definition, students, for numericals is much better than trying to solve your numericals with the earlier definition. This is preferred definition, okay? Preferred for numericals. Convergency is equal to the difference between a great circle direction measured at each meridian. Now, convergency is definitely the angle of inclination between two meridians measured at a given latitude. And it is equal to the difference between a great circle direction measured at each meridian. So if I tell you that you are traveling from A to B, and let's say the meridian of point A is something and point B is something, and if I tell you the latitudes also, and if I tell you the great circle track to start from your departure point, if all this is given to you, and the question would say, what is your great circle track when you're arriving at your destination? So the difference between your great circle track changing at your departure meridian to your destination meridian would only be the convergency value. As good as that. So how do you know whether to add or subtract? Whether to add or subtract to your directional value to get your new direction and your destination. It is this easy actually to find out your directions to fly to reach a destination following a great circle track. So to reiterate, what are we doing? Actually, we are trying to determine the directions to fly from A to B, finding out the shortest distance between those 2 points. And the shortest distance is the shorter arc of a great circle. So the direction that we are finding is actually a great circle track. Great circle track is the direction to fly to maintain the shorter arc of the great circle. And what do we know about great circle tracks? The directions, they change depending upon whether you are in the northern hemisphere going westerly or northern hemisphere going easterly. So you have to remember that if you are going in the northern hemisphere westerly, whether the directions increase or decrease. This is 315, 270, 225. Simple. It's become so easy for me to do, but the technique remains the same. You'll make this plus symbol. If you're going west, then this is how your directions are. 315, 270, 215, like this. If you're going east, like this, so you get 045, 090, and 135. Your directions increase in the northern hemisphere. In the southern hemisphere, what happens if you're going westerly like this? You get 225, 270, and 315. Your directions are increasing. And in the southern hemisphere, if you are going easterly, so this happens. What is this value? 135, 090, 045. This relationship is very important for us to know if we have to make our numericals very easy. So if you're going westerly in northern hemisphere, what will you do if your initial track is this 315? Then your destination track would only be the deduction of the value of convergency from 315. That's how it will be. Why deduction? Because traveling westwards in the northern hemisphere, my great circle track decreases. So this is decreasing, this is increasing, this is increasing, and this is decreasing. We are dealing with directions. We are dealing with convergency. We have a formula to find out the convergency. We will be given one great circle track at least, and we only have to add or subtract our convergency value to get our other great circle track. It is that simple, okay? Remember these points and your job would be very easy. So I'm going to give you all a question now. And one more thing I want to discuss. In reality, what actually happens is whenever we are solving the convergency formula for places at two different latitudes, what are we doing? We are doing a mean latitude solution, and then we do what? D long into sine of mean lat. I think that's the formula, right? So this mean lat, actually, what we are taking is for the ease for us to find out, but in reality, this figure is actually known as mid-latitude. Mid-latitude would be the midpoint between your departure and destination. So if your departure latitude is, let's say, the departure latitude is 49 degrees north, and your destination latitude is 44 degrees north, then the actual convergency formula takes in consideration the mid latitude between the two. Okay, but for our numericals, we use mean latitude because the difference between the two is very small. And for you as a CPL study student, this value is enough. The difference between the two changes when the D long distance changes considerably, but we don't do a lot of D long travel that way to let that impact us. So instead of mean latitude, in our calculations, we use mean latitude. But in reality, the convergency between the two will be perfectly figured out if you use mid latitude. So the latitude between the two. Ideally, the answer is the same, very close, whenever your D long distance is not much. So we take mean latitude 49 plus 44 upon 2, and whatever we will get, we will use that in the formula. This is some extra information so that anytime if mid latitude comes anywhere, you don't get confused and you don't be that person who says, no, there is nothing called mid latitude, there's only mean latitude. Okay, remember this point. So Vajit, go ahead.
The coordinates I sent you in chat box, can you please see? I have a question regarding that.
What about it? What's the question?
Sir, the question is, suppose if we are flying from A to B, then we are flying the great circle path. So according to this DIID rule, so our great circle will increase or decrease. By how we will judge that? Because one is in southern hemisphere and one is in northern hemisphere. So among northern and southern hemisphere, which hemisphere we will consider?
This was discussed, Subhojit, day before yesterday. Try to recollect. I'm going to show again. I think Varad or somebody had asked the same question, and I told you all it would follow westerly and easterly. Obviously, there would be a southern or a northern angle to your direction also. But you're going to follow what is closer. If you're going westerly in the northern hemisphere, and if you're starting from northern, then you'll follow northern western. If you're starting from southern, you'll follow southern western or southern eastern. So for this example, if your departure is 10 degrees, 20 degrees south and 010 west, and your destination is 50 degrees north, 010 east. If these are the 2 points, students, then with respect to great circle track, what would we follow is the question. So always first the strategy, and this is something that we are learning today. Okay, whatever calculations we are going to do, we are using this. So everybody is not just this doubt, it is something that we are going to solve. You should be very careful with it. Focus, you are going from A, which is 010 west, 20 degrees south, to B, which is 010 east, 50 degree north. So the first thing that you need to be careful about is making the meridians. One is in the southern hemisphere, the other is in the northern hemisphere. So what is going to be like, you just make your equator like this, okay? Then make your meridian for A. 1010 west. West will be on the left side. So I'm making it like this, okay? And this is 010 west. And with respect to it, where is 010 east? It is on the right. So I'll make it like this. This is 010 east. Okay, now this is equator, 0 degrees north, south. Where is A located on 010 west? 20 degrees south. Where is 20 degrees south? If I take this as the center of the earth, then somewhere this I can say this is 20 degrees south. This latitude. So 20 degrees south. 20 degrees south on 010 west, I've got it. I've got the meridian, I've got the location also. I'll simply just make sure that I don't get confused. This is that point. I'm just showing dotted line to show you my latitude on this point, 20 degrees south. And where is my latitude for Bravo, 50 degree north? It is somewhere here, 50 degree north. These are the 2 points. Now, what am I supposed to do? Am I supposed to fly from A to B? If I'm supposed to fly from A to B, then what will I follow? I have to actually fly this. I have to fly this track. What will happen to my great circle track, student? That is the question. You are in the southern hemisphere. You're going east. Southern hemisphere going east. Your directions are going to decrease. If this straight line, you are representing the straight line to be the rum line, then this is your great circle track towards the poles. This is how it would look like. So you have to stick to it. And if you see your directions, looks like 090, 045, and 030. Decreasing because you have started from the southern hemisphere towards east, that would predominate. Decreasing, decreasing. Simple. What is important is how you plot and how you understand. Now, students, one more important point with respect to what we are learning today is when you are at any given meridian, okay, when you are at any given meridian, your direction, your true directions, they get a reference north from this meridian only. This becomes your true north. And all your directions measured when you are leaving this point alpha is this angle only, like this. The moment you reach here, Bravo, your north with respect to Bravo would be this, the local meridian. So for you, the angle of the direction over here would be a smaller angle like this compared to this angle, which is a longer angle. I want everybody to be clear with this point. It is a new point. It is not something that only Subhojit is asking. What Subhojit asked, I have shown. But this is for everyone because this is something that we have to do. It's any 2 coordinates we needed, we are taking just the same 2 coordinates. So this would become a rum line over here, and this would become a great circle track. Very simple. What I'm trying to say is one more important point. The true north reference for your point of meridian or your position, your point, the meridian of which is the reference giving you north. So it will change. The moment you change your meridian from A to B, your north changes. B to C, your north changes with respect to your earlier north. Remember this point, okay? Subhajit, are you clear?
Yes, sir.
So this is great circle track at B, this direction only. It's a smaller angle. And this is your great circle track at A. It's a larger angle. It would be slightly more than 090 in this case. But as you go up, it is only going to decrease. It's not going to increase. If somebody tells you that, sir, ideally I should go like this and then like this, then you can try that also. Okay, I can prove that also. that half in the northern hemisphere, half in the southern hemisphere, while this is your rhumb line. Then it stands true. Half stands true for what you did in the northern hemisphere, half stands true for what you did in the southern hemisphere. But you don't need to do these many changes in your flight, because if you follow the same path, you're still going to reach. That would be much more easier than going through this. But this is also a possibility. Your directions would decrease, decrease, decrease. Then the moment you are in the northern hemisphere, what will happen? In the northern hemisphere, going eastwards, direction increase. If you're doing that, then 0, 0, 0, 0, 4, 5, and almost 0, 9, or 0. So half of the hemisphere, your directions would decrease, 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 following southern hemisphere eastwards. Then in the northern hemisphere, your directions would increase, increase, increase. This is also possible. Okay, both things are possible. It depends upon you what you're choosing to fly. And if you're doing this, great. You need to know what is the total changeover at the midpoint, then that is on the equator. Such questions can also come. You can stick to that also. It will be true that your rhumb line is closer to the equator while the great circle is closer to the poles. But if you don't do this, if you do the earlier one, blue one, still you're going to reach your destination. Follow it. Okay, students? You can prove both the things. Both are possible. All right? So I'm going to give you all an equation. Students, if you have any more questions, feel free to ask. I'm going to give you one equation. Very simple. It will be there in your notes also that I'm going to share. Subhajit, are you following?
Yes, sir.
Everybody good? You're good to go?
Affirm, sir.
Affirm, sir.
Example A. Example is this, example 1. Your A is 40 degrees north, 40 degrees 00 minutes north, and 002 00 minutes west. Bravo is 50 degrees 00 minutes north and 010 00 minutes east. The question is, the initial great circle track from A to B is 60 degrees. True. What is the final GC or great circle track at B, and find out the great circle track at B to A. Okay, at, or you will replace the word from, and find out the great circle track from B to A. Now from B to A, don't get confused, because you have been asked two things. You have to find out the final great circle track at B, and then you have to find out B to A. Now, what do? How do you solve this? Everybody try to quickly first make your meridians. Okay, 020 west, 010 east. Looks like Earth's front view only because the D long is very less. And which hemisphere? North and north. It is northern hemisphere. So I'll make two meridians like this in the northern hemisphere because they are converging towards the poles and diverging towards the equator like this. Now, west to east. A is on the west one. So this is 002 and B is 010 east, 010 east, west. I've got my meridians. Okay, now I only have to plot my latitudes. So 40 degree north on A, wherever you make your equator, you don't really have to plot it. Okay, this is just your equator if you want. Then where is your 40 degree north? You could make your 40 degree north here, point A, 40 degree north, and point B would be a little higher than because the latitude is 50 degree north. So if say this was my 40 degree north latitude, this is my 50 degree north latitude, like this. I'll erase the dotted lines. So I've got my A and I've got my B, both. Now I have to verify if I've drawn it correctly or not by looking at the information given in the question. And it says that the initial great circle track from A to B is 060 true. So from A to B, your great circle track is going to be this angle. Your local north, this angle is 060 degrees true. And you're going to fly this true direction of 060. That is your initial great circle track. Now remember, northern hemisphere, you're going easterly, your directions are going to increase. So we know that our comparison with respect to the great circle and drum line it is like this. Okay, so this angle I'll correct it and I'll make it like this. This is my angle, 60 degrees, because I had to show a little bit of curved line. So this is 60 degrees. I've not made the rum line, but you can always make the rum line also because we'll need to do it in next questions. Make a straight line like this, which would be a rum line. Now, if you see this is 60 degrees, your final angle, what would it be? The question is, find the final great circle track at B. It means you need to know this value of this. What is this value? And this has to increase. And remember the definition, the earlier definition that I said, it is equal to the difference between a great circle direction measured at each meridian. What? The convergency. So what you do is you find out convergency and then use northern hemisphere easterly increase to find out this as difference between two GC tracks is equal to convergency, like this. So what is my convergency? Convergency is equal to D long into sine of mean lat is equal to, do I have my D long, students? What is my D long? 0002 west to 010 east. I think my D long is 12 degrees. Can anybody confirm if what I'm thinking is right or wrong? Is my
But
D long
isn't the
12 degrees?
blue line a great circle?
See, the curved line in this diagram is the great circle. The blue line is rum line. So
But
yeah,
it
what
should
you're
be
saying,
above, right?
yeah, it should be above. Good, students. Thanks. This one. Very nice. So this is your 060 right now. Good. Make this correction, everyone. What we had made was on the southern hemisphere. This is how it should look like in the northern hemisphere. Okay. So 060, it is going to increase. It is going to increase. Fine. At B, the difference is going to be only the value of what do we say? The convergency. We are trying to find out the convergency. What is D long, students? 020 west to 010 east. How do I find my D long? North pole, prime meridian, 002 west, so 2 degrees over here, and 010 east, so 10 degrees this side. So I have a D long of 12 degrees. So 12 into sine of mean lat. What is the mean lat? 40, 50, 40 plus 50 divided by 2. Okay. Students, I am going to show you how to use the scientific calci also. So please make sure you look at it carefully. If anybody is confused, it is there. I'm sharing a picture, a live video. I hope you all can see it. And I'm going to... Can everybody see it? Now simple, 40 plus 50 divided by 2 gives me 45. Are you able to see 45? Okay. Okay. It's where you see me in the video, you will be able to see this. So 12 into sine of 45. Now, how do I find sine of 45? I simply press this button, sine. I click 45 and I put this 0.70. Is everybody getting the same value, sine 45? Yes, no, you can just do something or the other, okay?
Yes, sir.
And then 0.07 multiplied by 12, I'm getting 8.48 is equal to 8.48. Now students, this 8.48, if you have to convert into your degrees and minutes, so remember 8.48 would be 8 degrees, and 0.48, there is a very easy way to convert it into degrees also. You will press 0.48, whatever your decimal value is, 0.48, okay, and then you will multiply it by 60. Okay, this I'll teach you when you're doing time also, and you will see 48.48 stands to 8 degrees 28 minutes, and that again 0.8, if you want to convert it to seconds, 0.8 into 60, you get 48. So this is actually 8 degrees 28 minutes 48 seconds. What is the value of your convergency, students? This I can round off in general 8 degrees and 30 minutes, or 8.5 degrees. Anything is true, accurate, or rounded off values. If this is your convergency, 8 degrees, 30 minutes, or 8.5 degrees, what would be your great circle track at B? It would be the difference, and your great circle track at B has to increase. So 60. So 60 plus 8.5, you get 68.5, which would be your great circle track at B. At B, this direction is 60 plus 8.5 is equal to 68.5 degrees, or how do you convert it into direction? It would be 068.5 degrees north, like this. And not necessarily north, I mean, this is just the value of directions between 0 to 360. So your any directional aid would be between 068 and 069, sharply in between the two. So this is your great circle track at B. Now you have got this first part of the answer. What is the final great circle track at B? It is 068.5 degrees. Okay. What is the great circle track from B to A? Now they are asking me, what is this track? B to A is this direction. Initially, the reciprocal of what was at B is what I need to find out. So B to A is the reciprocal of what you have at B. And how to find out the reciprocal, students? Everybody look at the screen. This is your CX3 emulator. Whoever doesn't have this emulator, you'll let me know. I'll share the link with you all. How do we get reciprocal to and from? Very easy way to get your reciprocal. Enter. You simply put to or from any which you're going to B was 068.5. You get your answer. It is not taking answer in points, so it's rounding off 69 to 249. So your reciprocal is 248.5. 068, 248. So 068.5 would be 248.5. So your great circle track GC at B is GC at A plus convergency, bracket, by definition, is equal to 60 plus 8.5 is equal to 068.5. Now the Bravo answer, GC from B to A is reciprocal of GC at B. That is 068.5. How do you find reciprocal otherwise? You just do plus 180. Whenever the answer goes above 360, subtract again 360 out of it. In this case, this is the reciprocal. I'll use my scientific calculator to do it. 068.5 plus 180 gives me 248.5 is equal to 248.5 degrees is my reciprocal track from B to A. So when I'm at B, students, if I'm coming back to A, this would be my track. And if I'm continuing to travel to B, then that would be my track. It is how it is. Think about it and tell me if you are understanding it. Tell me if you're confused. Sujal, convergency angle was correct. Subhajit, final track. Subhajit, 0.5, 69 degrees, actually 68.5. And from B to A, correct. Answer is correct. Thanks for the correction, students. It happens. I want you all to be alert. So very happy to see how you were able to tell me, okay, sir, make the great circle track about. And Vivek Dhakar, the answer is correct. Others, are you solving? Are you getting it? Are you confused? Let me know. Subhajit, any confusion? Anything, students, that you have read beforehand, and if it's contradicting with what I'm teaching, discuss with me, okay?
Sir, I have a doubt, sir. I'm just typing it with you, sir.
Sure, sure. Let's do one more example in the meantime. Everyone. Subhajit, don't think about it because I have not introduced this point yet. Okay. We have to make meridians are converging, and we know that the great circle compared to the rhumb line would be a curved line. That helps us determine that our directions are changing. Okay. So don't go there. We are going to discuss that. Wait. That thing is just basically a good thing to remember, but in your numericals, it can confuse. So whether you stick to that diagram or you make a combined diagram or you do this, it is all good. It doesn't really matter much in your outcome of calculations. So yeah. So that is something extra that students, when they go through the notes, they pick up like that. So don't worry about it. I know what you're saying, but it's okay. This is not wrong. Simple.
Sir,
Yes, Pankaj,
uh,
go ahead.
please explain how we get convergency at degree 30 minutes.
What is the formula for convergency?
Oh, sir,
Did
I
you-
got that, but I missed the Kelsey part, network issue. That's why.
Yeah. So yeah, that's what. So I'll start again. See, 12 is a D long and a mean lat is 45. The formula is D long into sine of mean lat. So I get 12 into 0.70. This is sine 45. Is this much thorough, Pankti?
Yes, sir.
Yeah. Now when I do this calculation in my scientific calci, I get this value. I'm going to show it again. Twelve multiplied by 0.70. I get 8.4. So this 8.4 in more digits, I was getting 8.48. You can still take it as 8.4 degrees. And this 0.4 degrees, if you want, you can convert into minutes also, is something that I was teaching. And if you want to convert this 0.4 into minutes, so you have 8 degrees and 0.4 into minutes, you simply take 0.4 into 60. Whenever you have to convert decimal degree into minutes seconds, you will multiply it by 60, the decimal value. This is something extra. And 0.4 into 60 is giving me 24. So this 8.4 degrees is actually 8 degrees and 24 minutes. Because I was taking an extra digit. Remember, students, I've told you all we have to take either 2 or 3 digits in our calculations to get more precise answers. I was getting this. This 8.4 is rounded off to 8.5 degrees for ease of your calculation. Even if you don't do it, still your answer is going to be very close. So your convergency is 8.4, or you can say 8.5 degrees, or you can say 8 degrees 24 minutes, 8 degrees 28 minutes, or 8 degree 30 minutes. In your calculations, you will always be trying to use your rounded off figures only to make your equations correct. Pankti, are you following? How did we get 8.5? What are you getting? Are you getting 8.4?
Yes, sir.
That is fine. You stick with 8.4 and you find your answers with 8.4. So you will realize your answer is 248.6 or 248.6 mostly, or yeah. So in your options, you will either have this number or that number. Your options generally will not completely match. Your options will be close to the answers that you're getting. Does that clear your doubt, Pankti?
Yes, sir.
What is the final answer that you're getting? Let me know once you find it out.
Yes, sir.
Students, these concepts, they have a lot of ways that you can solve them, okay? This is the most easiest way to solve.
248 decimal 4, sir.
Good. It is close to 248 decimal 5. Same answer. Good.
Hmm. Good.
I'm not teaching you all the other method, students. It is only going to confuse you all. So I want you all to stick to this. But when you'll be going through the notes, be alert for the second method also. Try to go through it. If you understand, great. If you don't understand, let me know and put it in your parking lot. In future, when we have extra time, I'll teach that second method also to you. Okay. But I think Vivek and Nandini and Sujal, you know the second method also. I think so. I'm not sure if you remember, but I want you all to just stick to this method because it's very easy and it gives you answers very quickly. Okay. And when you go through the notes, if you see the second method, if you want to learn, if you don't understand reading the notes, send it to me when you're going through the notes on WhatsApp and put that in your parking lot. Subhajit, all good at your end? Bharat, Manan, Vivek?
Yeah, sir.
Subhajit,
Yes.
don't let your mind think that what you have read in Oxford and what I'm teaching is different. It is not different. Okay? Don't get restless about it. Remember, whatever I'm teaching should be more important to you for your exams. Please use these strategies. And whenever there is a conflict, it's not going away from your mind. I should be the first person to know after the class. It's for everyone, students. Let's quickly do one more. Write down point number A is 36 degrees 00 minutes north and 015 degrees 00 minutes east. Bravo. My latitude for Bravo is 42 degrees 00 north and my longitude is missing. Now the question is, initial great circle track, okay, from A to B is 300 degrees true. And final great circle track at D is 295 degrees true. Find out what is the longitude of B. A great circle track at B, okay. Final great circle track at B is 294. A, find out what is the longitude of B, okay, and what is the great circle track direction at longitude 011 degrees 00 minutes east. Students, I want you all to try this on your own and give me your answers in the chat box. Now, this is an indirect question, but it has everything given to you directly. You might be thinking, sir, how will I find the convergency? My D long is not there. Without D long, how will I get convergency? So what is the other definition for convergency? It's the difference between the great circle tracks. And both the great circle tracks are given to you. So the difference is your convergency. Convergency is given to you. You will replace that in the formula. So convergency, you will be knowing the difference between the two tracks. Then D long is something that you have to find out actually. And sign of mean light is also something that you can find out. It's given basically. You can find it out. So that D long, you have to find the value of your destination longitude by tracing the d long from alpha. From 0, 1, 5, whatever your d long is, you will go in the direction. Now, how do you know whether you go east or west in this equation? So you focus on your initial great circle track and it will tell you you're going east or west. And your initial great circle track is 300. That is westerly, students. 300 is towards the west, northwest. So you know you are traveling from west to east. And of course, you're in the northern hemisphere. And you can see your directions are also reducing. It stands true to travel westerly in northern hemisphere, your great circle track reduces. So your sketch, how would your sketch be? I'm going to help you all with the sketch. Northern hemisphere, I'm making like this. I know I'm going 300 degrees from one latitude to the other latitude. So 015 east is this. From here, anywhere, I'm taking a 300-degree route. 300-degree route is this, like this. Okay. I'm making this as a great circle track for my memory. I'm not changing it to a rhumb line or a great circle. It's just a great circle track. Why? Because this angle is 360. Why? Measured from your meridian, like this. 300 degrees. True. And what point is this? This point is A. And what is the latitude for this point? The latitude is 36 degrees north. So this is 36 degrees north. So your destination has to be 42 degree north, which is higher latitude. Yes, bravo. 42 degree north. Got it. And this meridian is the question mark. I want to find out the value of this meridian. And this angle over here, you have reduced by the value of convergency. So your final track anyway is given to you, which is 2905 degrees true. Final track. So your convergency is given to you, students. So my convergency is equal to d log into sine of lat. I don't know my d long. What is my convergency, students? It is 5 degrees. How? It is the difference between the great circle track initial and final. It is given to me directly. So if I don't teach you this method, then you will never be able to solve this question. That's why I say this anyway, this is a preferred method to solve. This definition is a preferred definition to solve. So I don't know my d long because I don't know what my d long is. I need to find out my d long first. Into sine of mean lat. Into sine of mean lat. What is my mean lat? 36 plus 42 divided by 2. I'm doing it in my Calc scientific. If anybody wants to see, you will request and I'll show you how to do it on scientific Calc. 36 plus 42 divided by 2. In the scientific Calc, if you directly do this, you're not going to get the correct answer. Okay. You have to make sure because the system is tuned to the degree function. So 36 plus 42 is equal to 78. And that 78 I will do divide by 2 to get 39. Whenever you're doing the whole equation in your scientific calculus, be very careful. Use brackets for every new function, only then your answer will be correct. So 5 degrees is equal to d log into sine of 39. What is sine of 39? Sine of 39 is 0.629. So what is the value of d long? I'll keep d long here. And this multiplication will become division over here. Like this. So 5 divided by 0.629 is equal to 7.94 degrees is what I'm getting. And the 7.94 degrees, I can also convert it to degrees minutes, 7 degrees. And 0.94 into 60 will give me minutes. Seven degrees, 56 minutes, and 0.4 into 60, 24. This is the accurate conversion of decimal degrees into actual D long. You can round it off to 8, or if you don't want to round it off to 8, keep it 7 degrees, 56 minutes, or you can keep it 7 degrees, 7.9 degrees, however you want to solve. This is your D long. Now, if this is your D long, you're going in which direction? You're going in direction west. So from 015 east, you're going westwards by 7 degrees, which is generally you can round it off to 8 degrees also, students. So if you're rounding it off to 8 degrees, then from 015 east, you're traveling 1, 2, 3, 4, 5, 6, 7, 8 degrees. So you get how much? 007 degrees east. Your D long is 8 degrees. 8 degrees west. Your D long. So my destination longitude is 007 degrees east. Longitude at Bravo is 007 degrees east. Nukul, go ahead.
Sir, where you get that the convergency 5 degree?
Look at this definition, Nukul, read it out. Correct? Can you read this definition, Nukul, quickly?
Yes, sir.
Convergency is equal to?
Equal to the difference between great circle direction measured at each meridian.
Okay, remember this. And now look at it. What is the question telling us? The initial great circle track from A to B is 300 and final at B is 2905. Do you have the two great circle tracks?
Okay, sir.
Now, can you find out convergency by the definition? It's the difference between the two great circle tracks.
Okay, sir. Okay.
How much is that? 5 degrees.
5.
That's how we got it. If we miss that point, then it's impossible to find convergency otherwise with the information given in the question. So in my formula, I have directly written down convergency is 5 degrees. Why 5 degrees? Why 5 degrees? By definition, convergency is difference between the two great circle tracks at the two meridians. Okay, good question. See, there's such key elements,
sir.
students. There are so many ways, reasons why you would miss out a particular instruction given to you. It's not just technical issues, network issues. Even in a live classroom, I have seen students daydreaming and missing a couple of points here and there because it happens. You know, our thoughts go out. They go out. They act like stray thoughts at times, and it's so difficult to bring it back. I've seen so many students just keep nodding their head in real classroom, and they just keep nodding their head even if say something funny also. It happens. So you have to make sure that you keep asking questions. I got it. My answer, students, did you see how did I get the answer? Take your time, take it easy.
Sir, is it
Bharat, what are you saying?
sir, is it okay if we don't if we take 7 degrees 56 minutes directly?
You can take 7 degrees 56 minutes. Or you can round it off. Mostly your answers in the options would be rounded off answers only. That's why we round it off. Everything that you'll come across, 80% would be rounded off as options also. So we make it easy. If you want to stick to 7 degrees 56 minutes, stick to that. You will get slightly different answer. You will get major meridian to be the same. You will get certain minutes extra added to it. Like somebody has given me that answer. Yeah, Vivek Dhakad had given me the answer. So your longitude at B is 007 degrees 04 minutes east. That is correct. That is more accurate.
Okay, sir.
Yeah. You can take your accurate answers, you can take rounded off answers because your options are going to be either this or that, and the other wrong options are not going to have such small variation that you have between your real answer and rounded off answer. They would be very different. They would be very different. And partly the second part of the question, what is the great circle direction between this at longitude? So you can assume your longitude A to be the same and this as your longitude B, and then you can solve everything again, find the D long, find the convergency, the sign of mean lat, and you will figure out the great circle direction like that. Or there is another way to do it. Generally, the technique given in a few textbooks is this, that 011 is midway between 015 and 007. Solution for B, as 011 is midway between A meridian, that is 015 east, and B, that is 007 east. Therefore, GC at 011 will be midway of GC at A, that is 300, and GC at B, that is 295. So what is midway between the two? It is just the mean that you have to find out. 300 plus 295 is equal to 595 divided by 2 is equal to 297 decimal 5 degrees is your GC at 011 degrees 00 minutes east. This is how ideally you are taught to make a solution to such questions, but you can still go ahead with the D long calculation, convergency calculation. An initial track is given to you 300. So if you take your D long between A and 011, then your convergency would be lesser, and using that convergency, if you find the difference, you will get the same answer. But there are many logical approaches to many questions, one of which is this. Any questions, students?
Sir, I didn't understand this last one.
Read it, right? Read it, Bharat. Read it. It's right there in front of you. Tell me what is the point that you don't understand while reading it.
0 and 1 is the midway between A and GC track. 0, 0, 1 will be midway.
Students, quickly see if you have any doubts, okay? And make sure if you have doubts, you're sharing it with me. Bharat, waiting for you. Where are you stuck reading these lines? I want you to tell me one point where you are stuck. What is it that you have not understood? Quickly, we are running short of time, Bharat.
So this GC track, the question is, like we need to find the midway between GC, between the A and B.
What is the question? Why are you not reading the question? Read the question.
What is the GC track direction at longitude? What is the GC track
Question
direction?
was saying find the GC track at this longitude, and we have to use a logical understanding that 011 is between 015 and 007. This you only found out when you first found out the longitude for B, that was 007.
Mhm.
And now when you observe this longitude is in between 015 and 007. The difference is what? 4 degrees. Are you getting it?
Mhm.
So the D long is 4 degrees between this and initial great circle track 300 degrees point. You are missing this point. You're missing what was there in the question. And in the solution, we have written as 001 degrees east is midway between this and this. GC will also be midway between 000, correction, 300 and 2905.
East. Okay. Ha, 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 ha.
Take your time. If you're still confused, write it in the parking lot, okay? It is okay. Students, see, 1.5 hours, we don't even realize it passes on so quick when we are trying to learn or do numericals. Now, what to do? We have more sums to solve. So what I'm going to do is, tonight I'm going to share notes with you all. And tomorrow again, we'll have to meet for at least 1.5 hours to solve a couple of more sums and solve a couple of departure sums also. Okay, we cannot miss that. So whoever cannot attend on a Friday, I know your reasons already. So you don't worry, you can go through the recording. Other students, please make sure that tomorrow also you attend live. Anyway, it's Friday, it's not a weekend, so I think you're mentally prepared to attend. And tomorrow, if we have to stretch, keep some buffer time in hand. We could stretch till 7 or 7:30 if need be. So keep that much time in hand for tomorrow. Make sure you read the notes as much I'm sharing end of day before tonight. And read it as much as you can. Tomorrow I'm going to show you the relationship between a round line track and a great circle track. We need some time to understand that. And then we are going to see a couple of methods to find departure distances also. Okay, students? Yes, no, maybe please acknowledge. I only am
Yes, sir.
listening from couple of students, like only
Confirm, sir.
Subhojit, Varad and Vivek. Others, I don't know if you're following. And Manan, of course.
Firm, sir.
So at least before going from the lecture, give me an acknowledgement, okay?
Affirm, sir.
See, students, most of what we are learning is going to be synonym to a few concepts that you will come across in Oxford textbooks. Okay. Because, but not always, because certain ways, certain methods that I'm sharing with you are much more easier than what is there in Oxford. Sometimes if we see certain methods mentioned in Oxford textbooks or other textbooks are easier, so we teach you those methods. It is like that. So if sometimes you come across something that is exactly in the textbook the way I've thought, you should not feel like अरे ये तो कोई भी इसके लिए मैं क्या पैसे दे रहा हूँ, ये तो मैं भी पढ़ लेता textbook में से. Definitely it is there for your reference, but don't think like that, okay? Because there's so many books right in front of me from where we are choosing the best possible methods to train and to make it easy for you. Okay, so it has to come aligned with certain books only, and whatever is original is what you will not find anywhere else. But if you read 2 or 3 textbooks, then you will find a combination. I'm just saying, don't be judgmental because I'm going to share notes with you all. Keep an open mind, and wherever you're confused or if you have doubts, share a screenshot with me on WhatsApp and put that in your parking lot so that we don't miss discussing that. Okay, students, very happy to see you all regularly. I'm going to see you all tomorrow also. Then you'll have a weekend gap over which you can do your assignment. So lucky for you, you'll have more time to do your assignment, that is solving questions. Tomorrow we are going to continue from comparison between rung line and great circle tracks and then departure. There are, I think, 2 or 3 formulas that we need to understand similar to this. So your job until tomorrow's class, if you get time, would be to revise and resolve the solved examples in the textbook and see if you have any questions. Okay, no more assignment. I'm going to take your leave, students. Anything bothering you, let me know. And thank you so much for being so nice. It's only going to take you a long way. Keep doing what you're doing. And I'll keep doing what I'm doing. And together we'll increase doing what we are doing and we'll pass with flying colors. You passing is me passing. So I want to pass. Please help me pass, students. Take care and see you tomorrow at 5 o'clock. Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Most welcome, everyone.